Oops, that's on the right page, right. Okay, right, so that was just me looking ahead. Let's get back to the right page. Here we go. Okay, so thanks for joining. So you may or you may not yet have had a chance to finish off doing bits and bobs from 3A and 3B on arithmetic sequences, obviously when we're adding on the same amount each time. What we're now going to be looking at is 3.3 leading into exercise 3C, which is geometric sequences. So this is where you multiply to get the next term. Okay, so 3.3 we will look at geometric sequences, so that's where we're looking at specific terms. And then next lesson on Tuesday we will move on to 3.4, which is geometric series, which is when you're adding up these terms which have been multiplied to get the next term. Okay, so just remember the difference between sequence when it's a specific term and series when it's adding up a load of specific terms. So you can see that these here are geometric sequences because we're doubling to get the next term, or we're timesing by a third to get the next term, or we're timesing by -2 to get the next term. Now it's called the number you're timesing by each term is called the common ratio, and that uses the letter R. And R is obviously cropping up a lot at the moment when they're talking about COVID-19. Okay, and this bit over here is very much relevant, talking about is R being less than 1. So this is very relevant to what's going on at the moment. Okay, so if R is less than 1, that means that the sequence is converging. So in the terms of COVID, that means that the number of people who are dying each day is going down. So if you've got an R of 0.5, then each day you'd be halving the number of people who are dying. Obviously, the second R becomes greater than 1, then that's exactly what we don't want. That's when the number of people dying each day is increasing, and that's, you know, when we get another peak and all of that stuff. So it's quite interesting that when they're talking about R all the time on telly, that's the same R that we're talking about here. So let's just go and have a look at a simple series. Then this will just sequence, excuse me. That will allow me just to explain that formula up there. If we just go and have the sequence 3, 6, 12, 24, clearly the first term is 3. And by the way, we still use the letter A for the first term, just like we did with arithmetic sequences. So we can see that A is 3, and clearly we can see that R is 2 because we're doubling. Now just go and have a look at this third term here, position number 3, N is 3. Now how do we get the 12? We take the 3, we times it by 2, and then we times it by 2 again. So that's 3 times 2 squared. So all this formula up here is showing us is that the power of R is 1 less than the position of the term. Okay, so when we've got the third term, it's position 3, 1, 2, 3. To get it, it's been 3 times 2 squared. So the formula for the nth term of a geometric sequence is this. So we're saying that if you're working out the third term, then it's the power of R to the 3 minus 1, which is 2. Okay, so if you want to work out the 10th term, you would have a power of 9, and so on. Right, so that takes you through example 8 and example 9. Yes, I don't think there's anything here that's too difficult. So we're told what the second term is 4. So that's going to be AR to the power of 1 equaling 4. Okay, we've got the 1 less power. And then the fourth term is 8. So AR to the power of 3, and again 1 less again, that equals 8. Now you've just generated a simultaneous equation here, okay? 2 equations, 2 unknowns. Now the way to solve that effectively is take equation 2 and divide it by equation 1. So A divided by A is 1, so A goes. R cubed divided by R is R squared, and 8 divided by 4 is 2. So R equals root 2. Okay, and then you can substitute back in to work out what A is. Once you know R, once you know A, you can then work out whatever term you want. So just work, well, you do lots of practice in 3C of questions like example 9. And then this third one is, I just wanted, I mean, it's easy once you can see it, but it's just worth having it explained to you rather than just being given a formula. Let's say we've got this sequence that they've given us here, 3, then x plus 6. And it's a geometric sequence. Now, how do we get from 3 to x? Well, we multiply by r. How do we get from x to x plus 6? We multiply by r again. Now, working backwards, that means because 3 times r is x, then x divided by 3 must be r. Okay? And similarly, x times r is x plus 6. So x plus 6 divided by x equals r. So x divided by 3 equals r, but so does x plus 6 divided by x equals r. So they are equal to each other because they both equal r. So we can go and say that x over 3 equals x plus 6 over x. And then obviously you've just got to do your algebra to generate a quadratic equation, solve it, and so on. And then for part B, we're working out the 10th term. Well, that's when obviously the power of r is going to be 9. Yes, then example 11 is a typical question as well. So we're being told what is the first term in this progression to exceed 1,000,000. So our unknown is now n, okay? We know that a is 3, the first term. We know that r, the amount we're multiplying by each time, is 2, okay? So we can go and set up that using that first formula we saw, okay? So we've got, we need, so a times 2 to the power of n minus 1. Now that specific term has got to be greater than 1,000,000, okay? So we're just setting it up that there is the specific term. Note how we're using n minus 1 because the power is 1 less than the term itself. That's got to be greater than 1,000. We've divided by 3. We've then used our log knowledge. Okay, we're logging both sides. Okay, we're then using the power rule to bring our n minus 1 down. We're then dividing both sides by log 2. Get your calculator out and work all of that out. Add 1 to both sides to make n the subject. N's got to be greater than 19 point something, so n is therefore got to be 20 or above. So the 20th term is the first one that specifically exceeds 1,000,000. And that's it, folks. So I would like you to try and get exercise 3C done for Tuesday, if possible, please. It's quite a long exercise, so do just dot around. So you know you're going to rattle through number 1. I just suggest for number 1, just do it by sight. All right, just do the first few. Just do some of them, and then B2, I was just suggesting perhaps you just do those. You've already got the PDF of this exercise, so all these slides you're looking at you should have already. And then let's have a really quick flick through. So there, just check you're okay with that. X over 3 must equal x and 9 over x. I think that was the second example I went through. Then we're working out specific terms. Yeah, then here we're just making sure we're using that formula properly. I don't think there's anything. Let's have a really quick flick through. I don't think there's anything that we haven't really covered in those examples. There's one of those log ones, another log one. Yeah, so then, yeah, so I haven't got around to doing those log ones. So just do a couple of those log ones, and then that takes us on to where we're going to be next lesson. Okay, guys, so that's it. If you could try and do some of 3C, please. We will move on to geometric series when I see you on Tuesday, I think it is. So have a good weekend, everybody.
Thank you.
Cheers, guys.
Thank you.
Thank you.
Bye, guys. Bye. Bye.